Okay, this one says consider the function of f given by this on this interval. Find the coordinates of all points at which the tangent to the curve is horizontal. So coordinates means x and y, right? Coordinates means x and y, not just x. So where's the tangent line horizontal? The tangent line would be horizontal wherever the slope is 0. So we're going to need our slope function. To find our slope function, we take the derivative, and we would get 4 over 3 times x raised to the 1/3. And what I did is I subtracted 1 from the 3 over 4. 1 is the same as 3 divided by, or 3 over 3, so that's how I got 1/3. And then I would do it again with the next one. I would drop the 1/3, so I would get 4 over 3. 1/3 times the 4 would be 4 over 3. And then I have to take 1 away from that, which would be x raised to the negative 2/3. Okay? So I'm going to simplify this a little bit because, I don't know, he just looks really nasty right now. I want to set this equal to 0 and figure out what it is. So let's change this a little bit. It's going to be 4x to the 1/3 over 3 plus 4 over 3 x to the 2/3. You see how I put this guy on the bottom because he's negative. Now he's positive. Okay, so now what I want to do is I want to combine those two together, because when I read horizontal line, I saw a vertical line underneath it. So I'm thinking I should have one fraction right here. So I'm going to find the same fraction. It'll simplify our problem too. I'm going to find what this is when I add them together. Now stay with me on this. To make this have common denominators, I would have to multiply this bottom by 2, or x to the 2/3, and I would multiply top times x to the 2/3. So what would I do with the 1/3 and the 2/3? Add them together and I get what?
1.
So I get 4x, and this would be plus 4 from this 4 right there. And on the denominator I have 3x to the 2/3. Okay, now if it equals 0, do I care about the denominator? No, I want to find out what on the top would make this equal 0. What would make it 0? 4x plus 4 equals 0. So it would be, I subtract to get negative 4, 4x, so I get x equals negative 1. So negative 1 is where we would find a horizontal line. But remember, it said coordinates, so we have to find the y value. What do I plug the 1 into to find the y value? The negative 1. I plug it back into this. Oh, that's nasty. Alright, let me write it out. Negative 1 raised to the 4th power, and it would take the 4th root of that. Oops. Alright, I messed up somewhere. Oh, take out the 3rd root, sorry. So the 4 is the power, the 3 is your root, so it's raised to the 4th power. That's going to be positive 1, right? And what's the 3rd root of positive 1? 1. So we have 1 for the first one. So it'll be 1. Then we're going to go plus. What do we get when we do this one? So it's going to be negative 1. Okay, the 3rd root of negative 1. What is the 3rd root of negative 1? So you have negative 1, the 3rd root. What does that equal? Yeah, it's negative 1. And then I have to go negative 1 times the 4, so it's going to be negative 4, which equals negative 3. So we have negative 3. Negative 1, negative 3 is what we get for that one right there. That's our answer for that one. Okay, let me erase all that work right there. Okay, now let's look at the second part. I didn't erase this because that was my f prime. Let's change that to f prime now. So this is f prime right here. Alright, so what do we have to do for the next one? It says find the coordinates of all the points where the tangent line of the curve is a vertical line. So a vertical line has a slope of undefined, right? So what would make this undefined? Whatever would you plug into x to make it 0? So what do I have to plug into x to make it 0? 0. So look, we're almost done with it. We have 0, and now we just have to find what that is. If I plug 0 into this, I get 0. If I plug 0 into that, I get 0, so I get 0. Ooh, yay. That one was a lot faster than the first one. It's like I did all that work for A, and then it paid out for B. C says, find the coordinates of all the points at which the absolute maximum and absolute minimum occur. Now, there's a vertical tangent line right here, right? Is there an absolute maximum there? Nah. There's not. It goes like this right there. Okay, there's no absolute max at this 0. But this one, I don't know if that's a max or a min right there. So this is critical points and endpoints. We have -1 from our critical point, but then we have to test out our endpoints, and some of you guys forget that. We got to test out our endpoints because our endpoints can have a max or min. Why? Because, okay, let's just draw this random curve. Oh, that's not a good random curve. Let's do it like this. Yeah. Whatever. Yeah, look at that little like action right at the end right there. Okay, if I have a boundary right here and a boundary right here, actually, I'm going to change this part right here. So this goes like this. Okay. If I have a boundary right here and a boundary right here, check that out. The absolute max is right there. Absolute min is right there. And even though I found a critical point right here, and this is a local minimum, that is not the absolute minimum. So what I'm going to have to do is I'm going to test all these. I have to find the points for each of these x values. Now I already did with -1. -1 is -1 and -3. What about -8? What do I get if I plug in -8? I know, I'm kind of scared about -8. I don't really want to plug in -8. But let's plug it in. We have -8. We have to raise it to, well, let's do the root first, and then we'll do the power. I did the root first because I think I know, wait, what is the 4th root of 8? Is it 2? No, it doesn't work, huh?
Where are you getting that?
Oh, wait, where'd I get 4 from? It's supposed to be the 3rd root, huh?
Yeah.
Oh, man. Whew. Makes my life nicer. Makes all our lives nicer. Oh, the power is 4. Okay. Man, not even translating fraction to exponents correctly. Okay, so that is -2. And we raise that to the 4th power, which is going to be +16, right? So this is 16. Now what about the +8?
Shouldn't it be 2 raised to the 4th?
So that's going to be a +2 raised to the 4th.
Which is still 16.
Which is still 16. Huh.
Eight?
Oh, I didn't add it. Man, I'm just striking out right here. Sorry. I'm glad you guys saw my mistake. Okay, calm down. Don't. Hey, put down your pitchforks. Calm down. Okay, let's do this one. What is the 3rd root of -8? That's -2, right? So I'm going to add -8 to this. No. Yeah, -8. Because I have to multiply. Let me just show my work. So I have -8, 3rd root. I have to multiply it by 2. That's going to be -2 times 2 is -4, not -8.
It's times 4.
Oh, it's times 4, not 2. And this is called the mistakes video. Alright, so I get 8. So I plug in -8, I get 8. What do I get when I plug in +8? Okay, so let's no. So we have +8 instead of -8. So that's going to be a 2 raised to the 4th power, which is 16. So I have 16 again plus. I'm going to plug in 8 to that one. Hey guys, pipe down. I know some of you guys understand it. Some other people need to pay attention though. So this is 2 times 4. So it's +8. So I get 24. All right. So which one has the highest y value? This one.
This is a hard one.
I know, right? After you do all that, it's like, huh? So we have 8, 24 is our max. And then, and actually it's technically just the 24 that's your max. 8 is where you find it. Your min is going to be the -1, -3. So your min is the -3.
It does say find the coordinates.
Oh, does it say coordinates? Oh, it says coordinates. Okay, so you have to have those coordinates right there. All right, so let me clear all this and then do the rest of our business. This says, for what values of x is the function concave down? So what do we need to know if it's concave down? Double derivative. Okay, to find concavity, we're going to have to find a double derivative. So here's our f prime. Oh, that's nasty. Okay, you guys ready to get down with this? Quotient rule. Derivative of the top times the bottom. Derivative of the top is just going to be 4 times the bottom, which is 3x to the 2 over 3 plus the derivative. No, I'm sorry, minus. Whew, almost messed that one up. Minus the derivative of the bottom, which is going to be 2x to the 1/3, negative 1/3, times the top, which is 4x plus 4. Okay, here, hold on, let me do that derivative really fast on the side. So if I had 3x to the 2 over 3, I would drop the 2 over 3. So I have to multiply 2 over 3 to 3, which just cancels out the 3. So we have 2. And then I have to take 1 away from that, which is really a 3 over 3. So I get negative 1/3. So that's how I get that. The bottom has to be squared. So I'm going to have this squared, which is 9, because 3 squared is 9. And then if I multiply 2 times this, I get 4 over 3. Wait, so I forgot my x. X 4 over 3. Okay, so this is f double prime. So to find out where it's concave down, right here, for which x values is at concave down, we have to see where this function is less than 0. So think about like an x-axis right here, and we have a function. We don't know what this function looks like, but if it looked like this, we got to find this interval right here and this interval right here, which would be these x values and these x values, where it would be below the x-axis. And so what we're going to do is we're going to try to find some x-intercepts, and then we're going to have to test to see if the line is, or the curve is below the x-axis or if it's above the x-axis. All right, so this is what it looks like. So we want to know if this is, where this is less than 0. So what we're really going to do is we're going to set it equal to 0 so we can find those x-intercepts. If we set this equal to 0, we really only care about the numerator, and because I can multiply both sides by 9x to the 4 over 3. So this would be 12 x to the 2 over 3 minus 2x to the negative 1/3. That's multiplying to 4x plus 4 equals 0. Alright, so I just multiplied the 4 and the 3, that's how I got 12. I should have distributed this at the same time as well. So I have 12x to the 2 over 3. We have minus 8x to the, that would be 2 over 3. And then minus 8x to the negative 1/3, 0. Now a little simplifying, we have two common terms, so that's going to be 4x to the 2 over 3 minus 8x to the negative 1/3 equals 0. Alright, let's further this by writing, instead of 8x to the 8 times x to the negative 1/3, 8 divided by x to the 1/3. So that means we have two fractions that we have to find common denominators for again. And if I find common denominators, it's going to be, the common denominator is going to be x to the 1/3, and I would multiply, see, I'd multiply this times x to the 1/3, and then multiply the top times x to the 1/3, and I would be adding these two fractions together, so I would get 4x minus 8 equals 0. Now, after, see, let me get rid of this stuff. After I get that, again, we only care about the numerator, so we get 4x minus 8, because if we multiply both sides by x to the 1/3, you get this. Then we add 8 to both sides, we get x equals 2. So at x equals 2, we have an x-intercept. So if we have a visual at x equals 2, we have an x-intercept. Now whenever you have a variable on the denominator, you also have to take into consideration of asymptotes. This has a vertical asymptote at x equals 0, so we also need to check that x equals 0. We have an asymptote right there. So in this interval, and this interval, we need to pick a number and plug it into f double prime in order to find out if it's positive or negative, if it's going to be positive or if it's going to be negative. All right, let's write down our simplified version of f prime first before we start having to plug stuff in. So let me get some room going on right here. Okay, the simplified version of f double prime was, or is going to be, well, we simplified the numerator. That was 4 x to the 2 over 3. That's a 3 right there. 3, and then minus 8x raised to the negative 1/3. And then our denominator would be 9x to the 4 over 3. Alright, so let's pick 1 first, just because that one is really nice and easy. So that's going to be my first tester point at 1. If I plug in 1, this would be 1, and this would be 1. And so we would have 4 minus 8 divided by, and this would be 1, so that would be 9. We get a negative 4 on top, so it's negative. That means we would be concaving down right here in this area because f double prime is less than 0. It's negative. F double prime is less than 0 here. Now let's try negative 1. So negative 1 over here, what would that give us? If we plug a negative 1 into this, we would have, negative 1 squared would be positive 1, and then we would take the third root of it, so it'd just be 1, so we would have 4 again. This one right here would be negative 1, the third root of negative 1, so let's write that out. Third root of negative 1 would be negative 1. So that means negative 1 times negative 8 would be positive 8. And then down here we have another even power, so negative 1 raised to an even power would be positive, so we have a positive 9. That's going to be positive, so we have f double prime greater than 0, positive, which means we're concaving up here. So that's a concave up, and now we check one more, this 3, which is not going to be that pleasant, but we don't have to finish it, we just have to know if it's positive or negative. So we have, 3 raised to the second power, then the third root of that, and that's going to be a positive number because, well, I mean, it makes sense. 3 raised to the second power is going to be positive, which we know is 9, and the third root of that is just going to be a positive number times 4, which is positive. Then we have minus 8, and we have a 3 raised to the negative 1/3. And so that negative actually doesn't make it negative, it just makes it into a fraction. So instead of writing it like that, I can say 8 divided by 3, the third root of 3. And so this is going to remain negative, but the question is this going to be bigger or smaller than that? Let's see, and then this one's going to be 9 raised, or times 4, sorry, not 4, 3, we're plugging in 3, raised to the 4 divided by 3. So this is just going to be positive. We don't really care about that. We just care about the numerator. What's happening here? Is this always going to be greater than that? And if we did some thinking, we could do some arithmetic here on the side, but this would always give us a positive result. So that means f double prime is positive in this area too. So we have concave up in this interval, which goes to positive infinity, and concave up in this interval, which goes to negative infinity. And back to our question, it says for what values of x is it concave down? Okay, so we don't care about those two intervals, we care about this middle interval. So x has to be less than 2 and then greater than 0 for it to concave down. Alright, for the last part is we have to use all the information that we got and graph it on the axis provided. The axis provided for me is down here. So let me write down the information that was important that we just found. We found negative 1, negative 3 to be where we have a horizontal tangent line. We found 0, 0 to be where we have a vertical tangent line. and those are points on my graph. We also found 8, 24, which is our max, and we also found negative 8, 8, which is, I mean, I guess that would be a local min or local max. I'm not sure yet. But those are endpoints. So let's graph those. We have negative 8, 24, which goes right there. I'm sorry, negative 8 goes up to 8, so it would be right there. 8 goes up to 24. We have negative 1, negative 3, which would be right there, and 0, 0. All right. So let's just connect the dots and see if it also follows the other piece, the last piece of information that we found, and that was that it's concave down from when x is less than 2 and greater than 0. It's only concave down in that area. So that's in this area right here. The first attempt would just be to connect these points, which doesn't show us any concavity at all. There's no concavity for this line. That's because the slope stays the same the whole time. So we gotta throw some concavity in here. So we could just kind of go like this and this, but then we're breaking other rules. Let's see if we are following all our rules. Do we have a horizontal tangent line at that point? Yeah, we do. We can make that curvy right there. Is it vertical at 0, 0? Well, I didn't do a good job of hitting 0, 0, but it's almost vertical right there. And then look, it's concaving down right here. Does that follow our rule right here? No, it doesn't. Okay, the only place that this is concave down is between 0 and 2. So between this and this, that's the only spot where it can concave down. And I'm concaving down here and up here. So let's redraw it here. So I can't concave down to get down to this point, so I'm going to concave up. And then when I get to this point, I'm making sure that I go vertical, because I'm supposed to have a vertical tangent line there. And then I'm concaving down right here, but as soon as I hit the 2, I'm going to start concaving up. Now we don't want to go too horizontal right here, because then we would be saying that we have a horizontal tangent line at 2, and we know we don't have that. So that would be my best prediction of what this graph looks like. If you're not sure, and if I'm right or you're right, go ahead and throw it into a graphing utility like Desmos.